We explored pointers, and I mentioned that they would be most useful once we also dive into more complex data types. Well, in this course section, we are going to dive into such data types where we then also see reasons or situations where pointers can be helpful. We are going to dive into the struct data type, and we're going to learn how this struct thing helps us structure our data and when we might want to use it. And for that, in this course section, we're going to learn what exactly a struct is and why we might want to use it. And of course, we're going to see it in action with some dummy code before we then, in the next course section, also use the struct concept or the struct structure in a more realistic project again. Now, for this course section, I prepared a little starting project, which you find attached. It's one file mainly, and then this module file. And in this structs go file here, you find a bunch of code which generally only does things we already saw before. I got a main function, I got a reader, and in the main function I'm calling the getUserData function, which is this function here, where I gather some user input from the command line so that I can then enter a first name, a last name, and a birth date. Then here I create a time snapshot. I get the current timestamp by using the now function provided by the built-in time package. Then we might be doing more awesome things. It's of course just a simple dummy example, so we're not doing anything here, but it would be realistic that we are building an app where we are fetching some user data and where we then do more amazing things with that data. Here I'm just printing it to the command prompt so that we see that all of that works correctly. And therefore, if you download this and create your own Go module with the go mod init command, giving it a unique identifier, you can then run this module, and in the command prompt, you are then prompted to enter your first name, your last name, and then also your birth date. And here I'm coming up with some date. This is not my actual birth date. And if I hit enter, then this is all being output down there, as you see, and therefore this application overall works. Now here we're not doing anything new besides this timestamp. The rest of that code is all code we saw before. But there is something special about this example and this simple use case, something which you will encounter in a lot of applications you'll be building. We have some data, first name, last name, birth date, and the created timestamp that actually kind of belongs together. Nonetheless, here I'm managing that data in 4 separate variables. And that's of course not wrong, but if you think about more complex applications where you might be dealing with users and maybe products and maybe orders if you're building an online shop, then you often have packages of data, you could say, where multiple pieces of data are grouped together. For example, this data here could describe a user of our application. And very often you might want to pass that data around in a package, so that if we had some other function that is responsible for outputting user data or for storing data in a database, we can pass the entire user data package to that function instead of having to pass individual variables. So the data types we learned about thus far are not enough. Strings and integers and floats and so on are all great for simple pieces of data, but if we then want to combine that data and describe a more complex entity like a user, then these data types do not suffice. And that's why Go has a special data type that we can use to group data together, the struct data type. And we have similar concepts in other programming languages. In JavaScript and Python and many other languages, we have so-called objects. And the struct is basically Go's equivalent to those objects, in case you did work with other languages before. Now, in Go, in our Go file, outside of the function, just in the file like this, we can define our own data type, our own struct, by using the built-in type keyword. This tells Go that we want to define our own data type because the built-in types are not enough. Then we can give this type any name of our choice, for example, user. But that name is up to you. And again, you can start with an uppercase character if that type should then also be available outside of this package, in case you split your project in multiple packages or you distribute it as a third-party module. And you can start with a lowercase character if that should be a type that's only usable inside of this package. So just as you learned it about variables and functions, the same thing applies to this custom type. Now here I'll go for an uppercase character, because here it doesn't really matter to me whether that's available outside of this package or not. And then we need to add the struct keyword. With that, we are telling Go that we want to define our own type, and that this type should be a struct thing, a structure, so to say, an object in other programming languages. Then we add curly braces, opening and closing, and between those curly braces, we can now describe our own data type. Because keep in mind, the idea behind the struct is that we group together related data. Now, between those curly braces, we can simply define the different data fields that we want to have in this struct. And here you can come up with any names for these fields you want. Like, for example, a first name. A user should have a first name, we could say. So here we then just add first name, just as if we would be defining a variable, but without the var keyword. And then you need to define the type of data that should be stored in that field. And here that could be a string. And that's how you now define a user that will have a first name field, which is of type string. And if we later want to create such a user struct in our code, so if we want to use this blueprint, so to say, to create a concrete instance of that blueprint, we will be able to assign data to that field. And of course, you can also add more than one field. You can also add a last name, which is of type string, and then maybe a birth date, which is of type string. And the names I'm choosing here happen to be the same names as I have them down there for the variables, but you don't need to use the same names. You can use totally different names here. You don't need to pick up those variable names. But now I got that. I'll also add a created date here. And here the type will actually be a special type. The type will be time.time. And that's a strange type which we haven't seen before, but this is actually just a custom type defined by Go. If you hover over it, you see it's a struct, but not a struct defined by us, but instead, this is coming from the time package, which is built into Go, so it's a struct defined by the Go developers. So besides integers, strings, floats, and so on, so beside these basic types, we can also define our own more complex types, and there also are a bunch of predefined more complex types that are part of some of the Go packages, like this time struct type that was defined by the Go developers. And now with that, we're saying that we will have our own data structure called user, which will have these data fields. And we can now also use this as a custom type. And therefore, in the main function here, we could now say that all that gathered data should be grouped together into such a user object, into such a user structure. For this, we could, for example, already define a variable here, default user or new user, for example. Name is up to you. And make it clear that the type of data that should be stored in this variable should be user. And of course here I'm picking up my own type, because again, We can define our own types with that struct concept, and we can then, of course, also say that a certain variable should only be allowed to hold such kind of data pieces then. So here in new user, we can't store a string, we can't store an integer, instead we'll need to store such a struct. But how do we now use this struct blueprint here to then create a concrete instance of it here in our code once we got all that data? Here we gathered all the data. Here we defined that we want to have such a variable. Now we can go to new user and store a value in that variable. And then here create an instance of our struct by repeating the struct name, user, and then adding opening and closing curly braces thereafter. And between those curly braces, we now insert the data that should be stored in the struct. And we got two ways of doing that, to be precise. We can either repeat our field names like first name, and then add a colon, but no equal sign, just a colon. And then after the colon, define the value that should be stored in that field. In this case, first name, this variable. So on the right side of the colon, I'm referring to the value that should be stored, and that's the value stored in this first name variable. On the left side of the colon, I'm referring to that field name where that data should be stored. And we can now repeat that. We can add a comma-separated list of all our fields here and also target the last name field and store the last name variable value like this. Target the birth date field and store the birth date variable value, a birth date written like this with a lowercase d because that's the notation I chose here, also to show the difference between left side and right side. And then we can add the created date field and store the created variable value in there. And that's how we can now create a concrete instance. Now, since this can get a bit hard to read, you can also split this code across multiple lines here. So you can also write this like that. And then hit the auto format shortcut. It's important that you have a comma after the last key value pair as well then, if you want to split this across multiple lines. And now we have a very readable way of creating a new instance of such a user data structure. And now that's what's stored in the new user variable. Now with that, instead of outputting all these individual pieces of data, we can refer to our new user variable now and try to output that. And that's what I'll try now. I'll save everything and then open up that terminal again, run this application again and enter some quick data like that. And we see that we get this kind of output here now. It's a bit different from what we saw before, especially that date thing here looks a bit different, but generally this is working and we are outputting our data, our new user data now. And the advantage is that we now have this data package, new user, which contains that grouped together data. And if we have a bigger application where we now also maybe have a function that saves user data to a database, we can just pass that entire new user struct to that function instead of passing the individual variables. And that, of course, can save us a lot of time, a lot of errors, and make code maintenance a lot easier in bigger applications. Now, there is more than one way of creating a concrete instance of our struct blueprint. And that's, by the way, important. We got the blueprint here, where we define our own type, and then we use that type to create a concrete instance of it. And that's what we're doing here. Now, there are a couple of ways of creating a concrete instance. Here we are using the struct literal way of doing it by using the struct name and then curly braces and then adding those key value pairs of our fields and the values for those fields. There are also other ways of using that struct literal approach though. For example, if you plan on keeping the order which you define here, so first name, then last name, then birth date, and then created date, as I'm doing it here, then you can omit those key names here. You can remove all those key names here as long as you keep the order. So that is then also fine. And then we could also move it back into one line if that's easier to read for us. Here I'll keep it split out across multiple lines. And that's of course a bit shorter, so that's something you might want to consider. You can also omit all those values if you want to. Now I'm just getting an error here regarding those variables because I'm not using them anymore, but creating an instance of the struct like this is also fine, but of course it will be an empty instance. It will basically be a struct with all those fields, but all those fields are initialized to their default null values. So for example, to an empty string here. And therefore that's of course very often not useful, but sometimes it can also be useful to create it like that. Now you can also, if I go back to the approach from before, where I do include the key names, omit individual key value pairs. For example, now I removed last name, but I have all the other values and I'm setting all the other fields. Now all those fields will be set to those values I'm assigning, and last name will simply be set to the default null value, which is an empty string. So you got a lot of flexibility regarding that. What's also done very often is that you create a helper function for creating a struct, so that you outsource the logic of doing that here to another place in your code. That can especially be helpful if you have a more complex way of creating such a struct instance. And I want to show that to you as well. I'll add a new function, and I'll add it right below the struct definition so that we always see that. And I'll name it new user. And this will be a function that's only responsible for creating new user struct instances. And the convention for naming that function then is that you have the word new in your function name and then the name of the struct that will be created, to make it clear that this is a function that will be responsible for creating new user structs. And here we could then, for example, say that we here expect to get the first name, and I'll just name it fname here, this parameter. It is of course up to you, that parameter name. That we get the L name, so the last name, and the B date for the birth date. I'm not getting the created date because I will now actually create that date inside of that new user function. So in that function, I now have my user variable, which I create here, and I use the user struct literal here to create a new instance of that struct. And I'll set first name to fname here, and I'll set last name to lname. And unsurprisingly, I'll set birth date to bdate, like that. And I'll set created date equal to the current timestamp. And for that, I'll actually take that timestamp creation here from the main function and remove it from there, because we can argue that it is a process that's only related to the creation of a new user struct, since we only use the timestamp there. And hence I'll put it into this new user creation function here and get my current timestamp here and then use that variable here for storing that created date. And then of course here in new user we can return this user struct variable here and make it clear that this function will return such a user by adding our struct type as a return value type for this function. And now we got this helper function which we can use from anywhere in our code if we want to create a new user struct instance, so that we don't have to use that struct literal code in those places. So here in main, instead of using the struct literal notation here, I can now just call new user, so this function which we added, and then pass my first name, my last name, and my birth date to that function. And now we again will have a new user if I save that and if I would run this code. So that's yet another way of creating such a struct instance. Of course, we're still using the struct literal notation, but we outsourced it into a separate function, which also does some extra work. It gives us this timestamp, and we can conveniently call that function from anywhere in our main code whenever we need to create a new user struct instance. And of course, that's still our goal. Keeping that main function and all our functions in general lean and focused on a specific task. And now we do have a function with the specific task of creating a new user instance. So now we know how we can define our own struct blueprint and how we can then use it in our code. Now I want to come back to pointers. Because in this code, which we wrote here, everything works, but it's not optimal. It's not optimal because when you call a function and you pass a value to a function, or if a function returns a value, that value is always copied. So for example, new user, this helper function, creates a new user struct and returns it, but what actually happens there is that a copy is created and returned. So actually, two user objects are placed in memory. Now, this one, which is created in new user, will be cleaned up relatively quickly because it's not required and used anymore once the function execution stops. But nonetheless, allocating and using two slots in memory just for the creation of one user object is simply not optimal. And structs are more complex than just strings and integers. They can store an unlimited amount of data in them. They can even store other structs in them. As we're doing it here, we're storing created date, which is another struct. As we see here, it is a struct defined by the Go team, and therefore copying such struct instances unnecessarily is something we typically want to avoid. Now, to avoid it, we can use pointers. Instead of creating our user value here and hence copying it, we can return a pointer to the created user. That way, we'll not duplicate it, but we'll only have it in memory once, and then we return a pointer to that place in memory so that other parts of our application can work with that stored user in that place in memory. And therefore here in new user, I want to return such a pointer. For this, we first of all need to annotate this return type and make it clear that we don't return the actual user struct, but a pointer to that value. And we do that by adding the asterisk here. That's what you learned in the pointers course section. By adding the asterisk in front of a type, you make it clear that you will not store a value of that type, but a pointer to such a value of that type. And then here, instead of returning the user struct, which is the value itself, we want to get the address of that user variable, so of that value in memory, and we learned that we get that address by using the ampersand symbol here. And now, new user creates a user, stores it in memory, and then returns a pointer to that value in memory. And now in the main function, we just need to tweak this line a little bit, because new user does now return a pointer. The new user variable, in which I want to store the returned value, expects a user value itself though, so not a pointer to a user value, but the value itself. Now, to make that work, we got two ways. We either change new user to be a pointer, but then we'll have to adjust all the places in code where we use the new user variable, because now this is a pointer, not the value. Or we still want a value, and we dereference the pointer which we get back here by adding a star in front of this. Dereferencing is the process of looking into that address, which we get returned by new user, getting the value, and then working with that value. In this case, storing that value in new user. Both is fine, and it simply depends on what your application does, whether you want a pointer to that user here in the main function or the user value itself. You can make either of the two approaches work. It really just comes down to what your application needs. And that is also something that will come over time with experience. Now let's build up on this struct and pointers knowledge. I'll add another function here, which I'll name output user details. Now this function should deal with a user struct. It should get a user struct, because that's the idea behind structs, that we can pass around the entire data packages. And here I want to get such a data package. And then I want to output some user data. So here I expect to get a user. You can name the parameter however you want, which is of type user. So our struct here. And then I just want to output this with the printf function here. And I'll just say my name is. Then I want to output the values of first name and last name. And I'll say in parentheses born on and output the date value here. That's my idea here. And then therefore here, the three parameter values which we need thereafter are the values that we want to output here in the same order as we referenced them here. And hence that would be the user first name, last name, and then also the birth date. But how does that work now? How do we get access to the individual pieces of data in the struct? We learned how we can output the entire struct. That's what we're doing in line 44. But how can we access the individual data pieces in cases like this, where we just need the first name and last name and birth date, but not the created date? Well, you work with a struct just as you work with a package in that case. You use the variable name that contains the struct, in this case this parameter, and then you use the dot notation. And with that dot notation, you then get access to those keys, to those fields that are stored inside of the struct. So for example here to the first name, and then separated by a comma for the next value that I want to output, the last name. And then another comma and the birth date. Now with this approach here, with line 48, we're outputting that user data in a more formatted way, and we now see how we can access the individual pieces of data that are stored in a struct. And you can also nest this in case you would need access to the created date, which is a struct itself, as we saw. You can also add a dot on that struct, so on that date time struct here, which is provided by the time package, and also dive into some fields or even functions that belong to this struct, something we haven't learned about yet, with another dot here. So you can chain, as it's called, multiple structs after each other and dig deeper and deeper into such nested structs as well, in case you need to. But here we don't need to do that, hence I deleted that line again. We just want to output the user data like that. And now here, instead of outputting new user like this, we could call output user details and pass new user to it. Save everything and then open up that terminal again and run our module again. And now if I enter some data here real quick, we see that output works. But there is a flaw with the current approach. And do you see which flaw that is? Well, we are again passing our struct value by value. So we are creating an unnecessary copy. Here in output user details, we expect to get a user parameter which is of type user, so our struct. And then we pass new user as a value when we call that function. Now, new user is not a pointer because we dereference it here. It is the actual struct value. And therefore, as we learned, a copy will be created if we call a function and pass that value to that function. So now we again created a copy of that user. And sometimes that is what you want, sometimes you want a real copy, but often it's not because of that wasted memory. So therefore, in output user details, it would be better if we don't get the entire user value, but instead again the pointer to that value. And hence here, we can change this and add an asterisk in front of the user struct type here to make it clear that output user details wants a pointer to that user struct. Of course, we then have to pass in such a pointer here, and we get that by again using the ampersand. Or if that's the main thing we do here, we might not even dereference the pointer here, which we got from new user, and remove this asterisk, so that we have a pointer stored here in the new user variable, and we then just forward that pointer. Now we just need to make sure that new user, this variable, wants a pointer in the first place, and we do that by adding an asterisk here in front of the type. Now we want a pointer here, we get a pointer here, and we then pass a pointer to output user details. And with that, it again works. And if we save everything and then open the terminal again, we can run this again and still enter all that data here if we want to, and it works correctly. But maybe you can spot something in the code which is rather strange about that. It is actually a bit strange that everything worked just fine. And why could that be a bit strange? Well, here in output user details, we are expecting a pointer. And we are getting a pointer. We changed all the code such that a pointer is passed into this function. Nonetheless, in this output user details function, I'm then using the dot notation to dive into the different fields of my struct. But wait a second, user isn't the struct instance, it's a pointer to that instance. So user actually is a variable that just contains the address to the user struct, but just the address in the end. So we are using the dot notation on the address here, not on the actual struct value. So that shouldn't work normally. And it didn't work before in the previous course section when we worked with integers and strings and pointers. Well, here we're simply using a little shortcut Go is providing to us. Theoretically, you would have to, first of all, dereference the pointer by adding an asterisk, and then wrap this in parentheses so that you first dereference it and get the value, and then you use the dot notation on that dereferenced value. That would be the correct way of writing this. But since this is a bit cumbersome, and it's a very common scenario that you get a pointer to a struct, but you then want to access fields in that struct, Go gives you a shortcut and actually allows you to use the dot notation on a pointer to a struct, and behind the scenes it will then automatically dereference it for you. That's a little convenience that's built into Go when you work with structs and pointers, because as you probably recognized by now, it is quite common to combine pointers with structs to avoid the unnecessary memory cluttering. And that's why this works, even though it theoretically shouldn't work. Now, to conclude this section about structs, there's one last important feature about structs that we should not skip. And it's related to this output user details function. This is a function that's really tightly coupled to the user struct. It wants a user struct pointer as a parameter, and then we access the different pieces of data stored in the user struct. So this function doesn't work without a user struct. And that's of course different from getUserData, for example. Despite the name, this is a fairly generic function. It fetches some input from a user, but that can be any kind of input, and it could be stored anywhere, not necessarily in a user struct. So that is a fine function, but output user details, since it is tightly coupled to this user struct, can actually be turned in a different kind of function that is supported by Go. And that is a so-called method. Methods are still regular functions, but functions that are tied, connected to a specific struct. For this, I'll cut it. It's technically not required, it could stay where it is, but I'll move it up to my struct definition so that we have both close to each other so that we can immediately see all the things that make up that struct. And that's important because this function will now soon also be part of that struct or be an important addition to this struct. We can connect it, officially connect it to this struct by changing this syntax a little bit. We can add a so-called receiver argument, which is a piece of syntax we haven't seen up to this point. Between the func keyword and the function name, we can add another pair of parentheses, and in those parentheses we can now define a single parameter that will point to a struct to which we want to connect this function. We could name it user and give it the type user. So just as we add parameters here in the main parameter list, but now in this special receiver arguments list here. Now we have a name clash, hence I'll remove user here in that main parameter list, though I want to emphasize that we still could accept other parameters if that function would need them, in addition to the struct. We can also still return a value if that would be required. It's still a regular function from that perspective, but it has this special receiver argument here. And this receiver argument is a Go feature that connects this function to the struct of which type the receiver argument is. So the receiver argument user is of type user struct, so this struct, hence this function is now connected. We can now also just name it output details because we already have that clear connection to the user struct because of this receiver argument. So repeating that in the function name is possible but redundant. Now this function can stay the way it is. The function body doesn't have to change, it still works as it did before. But we now call this function differently. Instead of calling it just like this as we did it before, we now instead call it on an instance of our struct. So we can use new user, which holds a pointer to this struct, and thanks to that shortcut which I mentioned in the previous lecture, we can use the dot notation on that, but now not just to access the different fields like first name and last name, but also to access this output details method. It's now listed here in this auto suggestion menu because of that receiver argument. So it's really an official thing supported by Go. So now we just call that function with that dot notation directly on new user, on the pointer or the concrete value, because of that shortcut mentioned in the previous lecture, both works. That's now how we call this function, which is tightly connected to that user struct because of that receiver argument. If we now save that code and we run this module, that still all works as it did before. It still works without issues because this is using this official method feature built into Go. And it's a great idea to turn functions that really only work with one specific struct into such methods, because you then have this clear coupling and you can use the dot notation to access that method on the struct for which you want to do something. So that is really a good feature which you should use whenever you have a function that is specific to a specific struct. Now in that method, I am using a user value at the moment, not a pointer. We can also expect a pointer instead by adding the asterisk here. Just as for the regular parameter list, both works and we have the same advantages and disadvantages. If we accept a pointer, we avoid unnecessary copying in the memory space, and therefore this is often the better choice. Of course, in cases where you want to create a copy, where you don't want to work on the original struct, you can instead also accept the value as we did it before. It again comes down to what your method does. Here, for just outputting some data, a pointer is definitely better because we avoid that extra copy, which would serve no purpose at all here. Hence, I accept a pointer here. And that's now how we can add such a method. A really useful feature for connecting a function to a struct if that function only works with that struct anyways. And that's also what we saw before on createDate, which is of type time, which is a struct built into the time package by the Go team. If we would access, let's say down here, new user createDate dot to dive into that time struct, we see a bunch of functions, methods as we know now, that are connected to createDate. So here the Go team defined a bunch of methods for the date struct that work with that struct only. For example, to return the day of the month of a specific date snapshot. So here we see that method feature in action for the built-in struct. Here we see how we can build it for our own structs with help of that receiver argument. Now that's it for this course section. We learned about another key feature, structs. Structs are great for defining your own pieces of data in cases where the built-in data types are not enough, or more specifically, for cases where you want to group certain pieces of data together. And you can group any kinds of data. Here we have a bunch of strings and another struct grouped into our own struct. So such nested structs, structs inside structs, are also possible. And then the great thing about such structs is that we can create them by using that literal notation here. And we can then pass around and work with those data packages instead of having to use all those variables over and over again in different parts of our application. Now, when it comes to creating structs, as I mentioned, we use that literal notation where we set all our key value pairs using the key names defined in our struct blueprint and then assigning fitting values. Or if we keep the order, so the order defined here, we could even omit those key names. So here I actually added them even though it's technically not required because I do have the same order of values as I expect them in my blueprint. So both approaches are possible. Here in this example, we also see another convenience feature which we can add to our applications, a creation function for our structs. It's a regular function in the end, but it does one main thing. It creates a new instance of that struct. It runs that struct literal code, and it even does some additional initialization work. In this case, it's creating this timestamp. Having creation functions like this saves us the hassle of running all that initialization code here over and over again in different places of our app. Of course, in this demo app, we only have one place where we do that, but in bigger apps, it would be very common to have different places where this happens, and then having such a creation function is very convenient. By the way, here where we call new reader on the buff.io package, we in the end also use such a built-in creation function, because it turns out that the reader which we get here is also a struct built into Go. That's just a side note though. Now we can then use structs to create them and store data in them, and we can also add methods on them, like output details which we added here. Thanks to this receiver argument, we can connect functions to structs so that those functions only work with those structs and are executed through the dot notation. And the dot notation is in general how we can dive into the data stored in structs. We can use it for calling methods, but also for diving into the different fields in case we need to work with that data, which is of course something we typically need to do at some point. Now, last but not least, it is worth mentioning those pointers again. Especially when working with structs, pointers can be important because without pointers, if we pass structs as a parameter to a function, for example, we always copy that entire struct. So we occupy extra space in memory, and we can save that by using a pointer. As a convenience feature, Go actually allows us to use the dot notation even on a pointer to save some extra time and avoid that longer form which we otherwise would have to use. We can avoid that because Go has this built-in convenience feature. And that's it for this introduction to structs. In the next course section, we're now going to practice working with them in a more realistic project, and then thereafter, we're going to dive even deeper into Go.